This is the third part of my demonstration of the use of the eCHT code here, which will talk about the computing cocycles. So here's the outline of what we want to do. I'm going to install all the cocycles for M4, the cohomology of cofiber new, using a little script called make all cocycles. I will then use do lifts to compute the action of eCHT F2 F2 on the cohomology of M4, collect the data from those lifts using collect, and then we'll look at some of the things it tells us. Okay, so let's go over here to A. So let's go down into, so we're in the directory here corresponding to A modules, and we'll go down into the directory for M4, and we will tell it to make all cocycles. Okay, so that's very, yes, if you say make cocycles instead of make all cocycles, it doesn't actually do it. There, let's try that. Oh, that works lovely. Okay, so you see here it's making quite a few cocycles. Not a surprise, because if you look at M4 here at the top of the page, you see that their dimension over F2 is reasonably large. Okay, but it didn't take very long. So now we will do all the lifts. Oh, before we do that, let's look at what this has done to the maps file. And remember, in the maps file before, all we had was a single map, namely the cocycle, the one cocycle that defined the extension, M4 going into M going to the suspension of M1. Now we've got all the cocycles 0, 0, 1, 0, 1, 1, 1, 2, corresponding to each of these cocycles we see in the cohomology of M4 here, 0, 0, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 0, 2, 1, 2, 2, etc. Okay, so now we'll do the lifts. Go all the way to filtration 60 or cohomological degree 60. And there it goes now. Okay, so now the start maps here are actually computing map applied to differential applied to generator. And then once it's done all the start maps that land in a particular cohomological degree, it goes over to the resolution of F2 and writes down sections, the sections that it has computed for the differentials, and does all the lifts at once. So it is doing all of the lifts in parallel, essentially, in that it does all the sections. It computes the section for a given bi-degree once, and then it does all the lifts that are needed using that section. So this actually means it's a good idea if you're going to compute a lot of chain maps to do them all at once, because then each lift is a little faster because it only has to compute the section once. Okay, so this takes it a little while. Another thing you can use this for, rather than just doing lifts of all the cocycles, is to find a minimal set of generators for eXT of a module. How you do that is you have it lift all the cocycles corresponding to generators in cohomological degree 0. Then look to see which of the cocycles in cohomological degree 1 are not in the image of eXT F2 F2 acting on that. There's a little script called missing, or missing gens, missing, which will tell you this. And then you add those few in cohomological degree 1 that were not already hit by the action of eXT F2 F2 on the eXT of the module, and do the lifts again. And now you repeat in cohomological degree 2, etc. Now, when you're working over A, of course, this is only going to be finite in a finite range. But if you're working over A of 2, this is a genuinely finite process, and you can write down a complete list of eXT A of 2, F2, F2 generators for eXT A of 2 module with F2. Okay, looks like it's done here. Yes, very good. Okay, so let's collect that results of that into something I will call all.action for the action of X-day, F2, F2 on there. And now let's look in all.action to see what it tells us. Okay, so remember here is the ext for the module M4. And down at the beginning, we see only the sort of obvious things that the identity acting on the bottom generator is the bottom generator. Let's see, 10F2, that's H0 acting on, H0 in F2 acting on generator, on the bottom generator is 10 here. Okay, so that's telling us the same as what we see from the vertical line in the X chart here. So the HI actions, of course, are not so evident, but you can see other things that may be less evident. Let's just scroll forward a tiny bit. See, there's something I'm looking for, this generator 3,4, cohomological degree 3 in the 8 stem. That should be 3,3 times of F2 acting on the bottom class, I bet. Ah, there it is. Yes, very good. Okay, you see that this class 3,4 here is 3,3, that's C0 in X of A, F2, F2 acting on the bottom class. Okay, so that shows you that in here, the class C0 is actually divisible by H1. Of course, that's already true in the cofiber of 2 as well. Okay, the most interesting thing I wanted to show you here, there are two things I wanted to show you. First, if we jump ahead to filtration 6, generators numbers 13 and 14. Okay, that will be up here. Generator Adams filtration or cohomological degree 6, generators number 13 and 14 are sitting here in the 30 stem. And we have two such generators. So let's jump up to those here. Okay, so here we see two lines for each of them, 613, 614. 613, the first line here, 613, 00, 613 simply says the identity element in the cohomology of F2 acting on 613 is 613. Okay, that's not news. This one's interesting though. This one says 610 in F2 acting on 00 is 613. Should read this as 613. Read this line as 613 equals, well, or is contained in, perhaps a better way to say it, 610 in F2 acting on 00. Okay, so let's go back and look at the cohomology of the Steenrod algebra briefly. 610 here, this is the cohomology of the ordinary Steenrod algebra, mod 2 Steenrod algebra here. In this 30 stem, in cohomological degree 6 here, we have this generator 610, that's generally called R or R0. Okay, so that element 610 acting on 00 here produces 613. Well, not quite. Actually, if we look down at the next pair of lines, this same line here, 614, is showing up in here. Now, here's how you interpret that. Remember, this is the chain map that's being reported here. So here's how you look at what's going on. These two lines are telling us that 610, in other words, R in the cohomology of the Steenrod algebra, acts on generator 00 by producing 613 plus 614. Now, here's how that works. If you let SG star be the A generator of E sub S dual to the cocycle SG, then here's what we have. We have the cocycle 00, which is the bottom, corresponding to the bottom cell of M4 here. We lifted that back to cohomological degree 6, at least here, and then we compose with the cocycle 610. Now, what does 610 do? It evaluates non-trivially on the generator 610 dual. Okay, so then if I look at what this chain map is doing, is it's sending 613 dual and 614 dual here over to 610 dual plus other generators. And when you apply the cocycle 610 to that, of course, it goes to 1. Okay, so looking at it in this fashion, you can see that what you're seeing in the chain map is, of course, the dual of what you're seeing on the cocycle level. So when you see a line like this in the all dot action here, you have to be careful to look and see that it's, I mean, that tells you that 613 is a part of the answer, but you look at the following entry and you see that 614 is another part. Okay, so if you simply look at the generators for E sub 6, and we go back to the chart here, we see that there are two of them. In this by degree, there's 613 and 614. We just need to see where both of those go under the map when we apply the cocycle 610. Okay, so that's how you should actually, you should be careful when you're doing that to make sure you don't leave off one term here or another. And actually it's, this shows one of the virtues of doing this calculation. If we just look at the chart here, we might be tempted to think that the answer would be 614 because this supports this nice little H-naught tower for a ways, the same way that R does in the cohomology of the Steenrite algebra. Okay, there's one other thing I wanted to show you in here. Let's go back to cohomological, to internal degree, not internal degree, geometric degree 11, the 11th stem here. And oh, there's the cohomology of the Steenrite algebra. Okay, so we'll be talking about degree 7 here in a second. Let's go over here and look at the summary I prepared. In the 11th stem here of x over a of m4, there's a class 1,4 down here. Now, this class 1,4, if you think about the 11th stem of the 11th stem for the sphere, you notice that the first class you see is in pH2 up here in cohomological degree 5. In particular, there's nothing in the filtration 1. That means this filtration 1 class here must project to something non-trivial on the top cell, the S4 sitting at the top of cofiber nu. Okay, so that means then this class must go to a generator to the generator sigma of pi 11 of S4, or in other words, pi 7 of the sphere. Okay, so this class 1,4 here is actually detecting a class I'll call sigma bar, a lift of sigma back to cofiber nu. Now, this H-naught tower here says that pi 11 of cofiber nu is cyclic. So that's telling us that pi 11 of cofiber nu is a Z mod 128, which maps onto the Z16 and pi 7 of S. And then pH2 comes in here. Remember pH2, the periodicity on H2 in Adams filtration 5 comes in and hits this generator number 3 up in filtration 5 here. Okay, and if you go back to, let's make this go back a few pages. 5.3 there. Okay, 5.3 there. We see that, in fact, 5.3 is 5.2 from F2 acting on 0.0. Okay, so what was 5.2 in F2? That was exactly pH2 here. Okay, so that confirms what we could guess from just staring at the long exact sequence here. Okay, so this is the other kind of thing you can get from this. Just knowing the X chart, we now see that the lift of sigma from the top cell back to cofiber nu actually generates all of pi 11 of cofiber nu. Okay, well, those are the main things I wanted to show you. There's more detail in that archive posting I talked about, and that archive posting is also available with the data set that John Rognus and I put up on North Store, and that has this DOI here, which you can use to refer to it, and you can go download the cohomology of the mod 2 Steenrite algebra out through degree 184, including all of the chain maps and all the differentials, and use this in your own exploration of your own modules you're interested in. Thanks.